Good morning. How you guys doing today? So I have a little bit of good news. We are not going to have any more tests for the rest of the year. I know you're sad. It's okay. What happened was once the governor chose to keep schools closed for the rest of the year, I looked at our schedule and there are certain things that I have to get done before the end of the year. And when I looked at the number of days we have left, or the number of classes we have left, and the number of topics I need to cover, I realized, well, just don't have enough time to put tests in there. So for the last classes that we have, we're just going to cover everything that we need to get done. So how are you going to get graded? Well, since the tests are all done, I don't even know if we had one this quarter, didn't we? You're going to be graded on your work that you do. So just make sure that you get it in and do well. If you get it in, you do well, your grade's going to be fine. Okay. So I'm not grading each assignment as in the percentage that you get right, but rather, you're going to get graded on completeness. If you get most of them right, you're going to be fine. Okay. If you're getting a lot of them wrong, which most of you guys get them right anyway, so no worries with that. Okay. So that's where we're going from here. So we are jumping past a couple lessons. I'm going to give it to you pretty quick. We're going to kind of jump around a little bit for the rest of the year. So we're looking at topic 11.4 today. But in order to do that, I have to go over 11.1, 2, and 3 real quick. They're not complicated. Okay, so we're talking about something called congruent figures. So this is more of an 8th grade concept. It's introduced in 7th grade, but it's necessary for 8th grade. So we're going to go over these 3 real quick, super fast and easy. First one is a translation. Translation is really simple. It's where an object moves left, right, up, down. That's basically it. Okay. Second one is a reflection. Now, a reflection, if you think about it, is a mirror. So when you look in the mirror, you see everything, but it's exactly opposite. So a reflection would look like that. Okay, so this would be reflected right here, and everything goes over. This one is reflect. So this is reflected horizontally. Vertically. This is reflected horizontally, and this is just another one that's down there, just so you can see. Okay. The next one is, let me move myself back. So this is just translation, so it can go like that, it can go like this, it can go like that. Wherever you want to put it, that's translation. Next one is, and the final third one is called a rotation. Not very complicated. Rotation is spinning it. Not very complicated. Okay. That's basically it. So all these things are called rigid motions. Now, basically, rigid motion is just its transformation. Now, preserves is a very fancy word for it. It just keeps the same length. All the sides have the same length, and all the angles remain the same. And we said that the rigid motions are translations, rotations, and reflections. So what in the world is a congruent figure? Well, congruent is very similar to equal, but it looks a little bit different. Okay. The sign is a little bit different. Some of you have seen it. You're going to see it in a minute. So basically, you have 2 figures, and you can get one from the other just by translating it, rotating it, or reflecting it. All right. So basically, it keeps the same size and shape. Angles stay the same. Side lengths stay the same. It just might look slightly different. So for example, you have that seesaw and that seesaw. Okay, these 2 are completely congruent. They look a little different, but I can just rotate this and I can get that one, and translate it and I can get that one. So it's all connected. So let's look at congruent figures. So congruent sign is this. It's just an equal sign with a little tilde over it. So it looks like an equal sign. It looks equal. They're basically the same thing. They're slightly different. Equal is one value and another value are the same. Congruent means one thing has the same measure as the other. That's generally how we use it. Okay, so let's go back to the Jamboard here. This is that same picture that we have on the slides presentation. Now, looking in here, there's a couple of things that you might notice. First off, here, you notice that with angle B and angle E, there's just one little curved line. In geometry, that's how we show the 2 angles have the same measure. So every angle that has that same measure would just have one little slight curve. Now coming here next to C and F, you notice there are two curves. That just means that C and F are the same. They have the same measure. What are they? I don't know. Okay, but I know that C and F have the same measure, angle C and angle F. But they are different than E and B. That's why you have two lines. And then for A and D, you have three lines. That just means that A and D are congruent, but neither A and D have the same measure as C or as B. Okay. Now, to do congruent sides, what we do is we use a little dash like that. So BC and EF are going to be congruent. So since they're different than ED, we would use two lines. And then AC is congruent to DF. So we would use three lines, just to say that those two have the same measure, but they are different than the other ones. Now there's this word in here called corresponding. Corresponding just means same location in relation. So for example, you see you have angle A and D. Now these are in the same orientation, so it's not that complicated to see. But if I were to rotate this, it would look a little different. It just means it's in the same spot. So the side between whatever measure A and D are and B and E, you have this side. We'll just go with the short side for right now. So the short side would be the corresponding side because it's in between these two angle measures. This happens to be the long side right here for both of them because it's also in between D and F and A and C, those angle measures. So that's just corresponding. C, it corresponds because it's the angle made by the longest side and the second longest side. Same thing with F. It's made by the longest side and the second longest side, so therefore those two are corresponding. E is made by the short in the middle. B is the short in the middle, so those are the corresponding angles. Okay. So when we look at this, the way we would write corresponding is very simple. So this is just saying line segment AB corresponds to line segment or is congruent to line segment DE. Does the order matter? Yes, it does, because you're going from this angle to that angle, this angle to that angle. So you have to keep the letters the same. So BC, okay, you're going from the short middle to the middle long. So here you have to go from the short middle point to the middle long. So it's congruent to EF. And finally, AC is congruent to DF. We would write it with angles. Again, it's the same thing. So angle just means it has the same measure or same size. Okay. So now we're going to look at just which of these shapes are congruent. So we're going to look at which of these shapes can we use one of the translation. So a translation, a rotation, or a reflection, or any combination of those to get one into the other. We're going to have a congruent figure. So this, I think it's pretty easy for you guys to see this one. Okay, triangle PMN is congruent to PDE. Now, how do you tell that? Pretty simple. If you notice that this length is 2 and that length is 2, this is 2 and that is 2, and this is a right angle and that's a right angle. So those two sides are going to be the same. So you can tell that with the size. Now, if you come here, which one of these is congruent of the last three? Well, it's obviously going to be these two. You can tell pretty easily. But if you notice, it goes down 3 and over 2. This goes up 3 and over 2. So, and again, it's a right triangle. So with a 3 and a 2, these two are going to be congruent. That's just the same one. Let's just come to this one. Now, this one and this one are actually congruent. Okay. So if this were to rotate up, you could tell that it was congruent. But how could we tell that without measuring these sides? Well, if you notice, to go from this point to this point, you go down 1 and you go over 4. Same thing, you get from that point to that point, you go down 1 and you go over 4. And the two sides are each 2. So now here, if you notice, that's 2 and that's 2. Now to get from this one to that one, you go up 4 and over 1. Up 4 and over 1. So again, it's the same relation. So this and this would be congruent. Please reach out if you have any questions. Have a good day. Bye.